For this example, we suppose that sine of alpha is equal to 4/5 for some angle alpha in quadrant 2, and sine of beta is equal to 1/2 for beta in quadrant 1. We're going to use this to find cosine of alpha, cosine of beta, cosine of alpha minus beta, and sine of alpha minus beta. So to find cosine of alpha, and for that matter cosine of beta, what we need to do here first is figure out what the last remaining value there would be. That is, what is x? So for alpha, we're given that y is equal to 4 and r is equal to 5. So accordingly, x has to be equal to the negative square root of 5 squared minus 4 squared, where it's the negative square root specifically because we are in the second quadrant, which means we get -3 for x. Similarly, in terms of beta, we have that y is equal to 1, r is equal to 2, and so this is a common angle. Hopefully you can guess, and you're not going to say it explicitly, but the angle beta is pi/6. In any case, we can use the Pythagorean theorem here, if we really need to get that x has to be √3/2. And if we have this, then we can just get our angles. Our angles are cosine functions at those angles. That cosine of alpha is going to have to be -3/5 appropriately, while cosine of beta is going to be √3/2, because I got ahead of myself. Of course, x is not √3/2. X is just 3. My mistake. Sometimes I just can't help myself getting a little bit ahead of schedule. In any case, from here, we can apply our difference formulas, where for cosine of alpha minus beta, we can use that formula to say that it is equal to cosine of alpha cosine of beta plus sine of alpha sine of beta, which here would take the form -3/5 minus √3/2 plus 4/5 times 1/2. Multiply those together, split the terms together, and what we will get is 4 minus 3√3/10. Similarly, for sine of alpha minus beta, we use one of the other formulas. We have sine of alpha minus beta is sine of alpha cosine of beta minus cosine of alpha sine of beta, which means we have 4/5 times √3/2 minus -3/5 times 1/2, which, again, pull them together, you get 4√3 plus 3/10. Essentially what we do here for these evaluations. And then the last thing we're going to look at from this section is our formulas for working with tangent.